Okay, Dakari, what are you doing, dog? Go. Okay. So, how do you convert factored form to standard form? I'll make sure I address that to start so I don't forget. I'll look at the rest of the questions in a second. So, which problem asked us to convert from factored form to standard form?
Part B.
2B, right?
B.
Okay, so 2B asked us to go from factored form to standard form. Now, I will point this out. I will read with your mistakes, but if you're going to get B right, what do you have to have correct before that?
Part A.
Yeah, part A, right. So if you made a mistake on part A, I will read with you. But what should the factored form be in part A? Say again? It's on your sheet though, isn't it? So look at your sheet. I'm going to write it in this so it shows up really well on the whiteboard. So, what should we have? X plus 2 and x minus 3. Notice that is representing what? That's the g of x, right? What are we doing to that g of x?
Dilating.
Dilating. What's the operation for dilate?
Oh.
Multiplication, right? If you want to make a note, that's extra evidence, right? So we're dilating by what?
Negative 2a minus 4.
Okay. That's what we should have up to this point. Okay? That's what we should have. Now, Brady, you said graphing earlier. Did you mean to do 2c, the graphing part, or did you mean to do 2b, the converting to standard form? So converting to standard?
Yes.
Okay. So 2b, part A, you wrote h of x in factored form. Convert that to the standard form of the polynomial. And Addison, I already heard you say this earlier. What do we want to use to help with that? The area model, right? Now, how many factors can we multiply at a time?
2.
Okay. So, which factors do you all want to do?
I think negative 2x minus 4 and x plus 2.
So you did these two first?
Yes.
Now, those are separated by x minus 3. Is that still okay?
Yes.
Yeah, that's totally fine. Doesn't matter which way you approach it. As long as you do 2 at a time, you're going to be fine. You just got to be careful with the details. What's x times negative 2x?
Negative 2x squared.
Okay, negative 2. And how many x's are we multiplying?
2.
2, so x squared. What's x times negative 4x?
Negative 4.
Negative 4x. What's 2 times negative 2x?
Negative 4.
Negative 4x. What's 2 times negative 4?
Negative 4.
There we go. And so, are there any like terms in this area model?
Yeah.
Negative 4x and negative 4x. Those are like terms. What's up, Kennedy?
I didn't want to get my iPad and my charger. My block. My nephew.
You what?
My iPad and my charger.
They're left in your last class? Let's go get that at lunchtime then, because you don't need it right now, right? So negative 4x and negative 4x. Those are like terms. What do I get then from this area model?
Negative 2x squared minus 8x.
Remember, those are both negative. So is it plus or minus?
Minus.
It's minus.
Oh, that was much.
So remember, well, not just that. If it was 4 minus a negative 4, when you have two negatives right next to each other, it becomes a plus. But when I have negative 4, that means I'm starting at negative 4 and then going which direction when I subtract 4?
Well,
Left. So I'm going to go to the left to negative 8. So you got to be careful and keep that in mind. By the way, this was also on the calculator portion, wasn't it? No, this wasn't on calculator. JK, never mind. I'll read with mistake. So negative 8x and then what?
Minus 8.
Minus 8. But that's not finished. That's only these two. What does this still need to be multiplied by?
X
a
minus 4.
minus 3.
So could your answer be different up to this point?
Yeah.
100%. That's totally okay. The only thing we need to keep in mind here is I'm going to do an area model again, but one side has to be what? Has to be longer. It's got to be longer. So, does it matter which one is longer?
No.
No. Yeah. Do what? A glue gun? Not with me. No, sorry, not even with me. No, I do not. I bet Miss Williams has one. Oh no, you're right.
They broke in first period.
Sorry. Do you want to move to that desk so you can see
I
what
can speak, but
We
they
can-
broke. I just wanted
yeah.
to be finished.
Yeah. How about I let you go a little bit before lunch and talk to Miss Williams, see if we can. Okay. So, negative 2x squared minus 8x minus 8. So how many columns am I going to need here?
Ms. Cannon, where'd you get the 8 from? I mean, the negative 8x.
Bakari.
Well, the other area.
What's wrong, man? Answer the question.
I know, but like we just
Okay.
discussed that, didn't we?
Come on.
That's a question we just answered.
Alright, my bad.
You're good. So how many columns? 3. Okay. And x minus 3. Do you remember I like to put my minus with the 3? It makes it harder to make a mistake. Got 2 rows, one for each term. What is x times negative 2x squared? Negative 2x cubed. Remember I have how many x's being multiplied? 2, and I'm multiplying by 1 more for a total of 3. Okay. Then what? I say you said negative 8x times x, right? Negative 8x squared. Right? Multiplying 2 x's. Tyler, you writing some stuff down to help improve your understanding? Okay. What's next? Negative 8. Uh-huh. Alright, next row. 6x squared. Remember, negative 3 times a negative 2 is 6. And we've got 2 x's being multiplied.
24x. 24x.
Mm-hmm. And 24. Alright, can I get one person to come up here and circle one set of like terms? Just one set of like terms. Alright, Matt, you can do the other one. Yep. Okay. Alright, are we in agreement? Are those like terms? Yes? What's your question,
I
Amber?
thought it was a number.
The first one, the 6x, 2, oh, I see it, because of the second, yeah.
X squared.
Yeah.
They're both x squares. Because
What
remember what
they
this
call
this means that I'm adding x squared 6 times.
Small numbers called again?
Exponents.
Yeah,
Mhm.
okay, it's going to be.
So this means I'm adding x squared 6 times, and then I'm taking away x squared 8 times. What do I have though if I have if I have x squared 6 times and I take away x squared 8 times? Negative what? Negative 2. So this, by the way, make sure that you actually have h of x equals. If you don't have h of x, it's not a function. Okay, so I should have pointed out, no like terms for the x cubed, so it just is. We had 6x squared, we took away 8 of them, so we have negative 2x squareds. And then I have 24 x's being added, and what am I doing to those 24 x's? Subtracting how many? And how many will I be left with? And I just have 24. This is the function that we should have gotten.
Okay, I have a question.
Yes, ma'am.
Okay, so what if you like did x plus 2 and x minus 3 in the area model first, then you have the.
It should give you the same final answer. You may have made a mistake somewhere. That should be what you get though.
I took the place and I did x.
Mhm.
Okay.
I mean, did you get the same standard form, girl?
Yeah.
Okay, then why are you asking? You got the same exact standard form. But look at it. Is that what you have written down on your paper? Look at it. By the way, but I will point again, Maddie, I just said this. Make sure you have h of x equals. Otherwise, it's not a function, guys. H of x equals is important. Jaquel, you taking notes back there? Because you don't even have that non-calculator section out. You got the calculator section out. There we go. Okay, what was the domain and range on that graph? Okay, so let's look at number 3 then. No, what is it?
That was on the other one.
That part C.
That's the other one.
That's number six.
That's 5C? No, it's 5B. Domain and range.
It's in the yellow paper.
Yes, it's.
Yeah, I was asking for the domain.
I know. Well, I was just looking at the next question. It says, what is relative extrema on number 3?
Or B.
This would be number 5?
On number 3 for B. On number 3. Okay. Go to number 3 and then go back. And then B for that. Does it matter that it's power to the third?
Do you mean what is the
What
degree?
you talking about?
Yeah, like, no.
Okay, but we can look at it, but Addison, that's not what this question is asking. The question is asking which function has at least 2 different zeros with a multiplicity of 3. You have 4 answer choices.
Okay, but does it matter at all? Like, does that change?
Okay. Well,
Is what I'm trying to ask.
okay, so let me show this. When I look at this b right here, what does it mean to cube the x minus 3? It means to multiply it how many times? 3 times. So really, Addison, what this really means is this. So, that's what we really have in that factored form, okay? X minus 3 cubed. So what are my zeros for this polynomial? What would be my zeros for this polynomial? Notice I said equal to 0. What is it? X equals 1. How many times does x equal 1? 2 times. So x equals 1 with a multiplicity of 2. What's another 0 in this one?
X plus 3.
X equals a positive 3 with what multiplicity?
1.
With a multiplicity of 3.
How? Wait, what would it be a multiple?
Because remember, this is,
Oh,
this is
three.
why I actually use the zero product property to make sure I don't make a mistake. Notice it's x minus 1 equals 0. X equals 1. X minus 3 equals 0. Notice x equals 3. Remember how it was always x minus r1 and x minus r2, so it was always the opposite? That's the
Yeah.
lid. Okay, so x equals 3 with a multiplicity of 3, and then x equals negative 3 with a multiplicity of 1. Does that satisfy the question of 2 different zeros with a multiplicity of 3?
Yes, that's x minus 3 to the third power, so I mean, we should did it 3 times. Is that right?
Yes, but the question is, which function has at least 2 different zeros with a multiplicity of 3? So, you think it's which one? B as in boy? But, guys,
I didn't do all this because I didn't know how to do it.
do you know how to find a 0? Maddie, we've been doing zeros since about a month and a half ago.
That is so bad.
Right here. How do we find a 0? We set the function equal to, and so what can we now use? So you know how to find a 0.
How do we get x minus 1? Is it because it's a double?
Well, it's x equals 1 with a multiplicity of 2, but we set x minus 1 equal to 0, right? So x equals 1. Notice that's also the 0 here, right? So how many times is it 1? Twice.
Okay.
How many times is it 3? 3 times. Now you didn't have to write down this full factored form. You could have just noticed, hey, I have that 3 times there. But again, guys, looking at the question, do we have 2 different zeros each, or at least 2 different zeros with a multiplicity of 3?
Yeah. Wait, hold on.
I see a multiplicity of 3 right here.
Oh, no.
Do you see another 0 with a multiplicity of 3?
Nah.
I don't either.
Me either.
That's what it is.
Okay.
Yes.
I ain't gonna lie, that question did make me up. I ain't know what they were trying to ask.
Man, I gotta remember
Okay.
that.
Okay, well, let's learn before the test, because that's it. That's all we're asking.
Is the test when we come back, like what day?
Wednesday, I think, is
Oh,
what we're
yeah,
planning right
Wednesday.
now.
This sounds good.
Is it C?
So let's check C.
Ashley, do you have book and card?
Right here. So, I'm not going to go through all the work, but what would the 0 be for this one right here?
5.
And check and make sure. What is 5 minus 5?
0.
0, okay, so x equals 5, and what would the multiplicity be?
3.
Let's see, we have x minus 5, how many times? 3 times, so multiplicity of 3.
Okay, man.
That's like an easy concept.
So
What is the 0 here?
Put 3.
So check and make sure, and what you really should do for the best understanding is literally set equal to 0, and then solve it, but yeah, x equals 3, how many times do we have x equals 3? Was that x minus 3 squared here?
Oh, yeah, that's the
X minus 3 squared? So I have 1 3 here, and how many 3's do I have here? 2. So x equals 3 with a multiplicity of 3. And then here, x equals, not 3, negative 3. Remember, again, this is why I take the time to set equal to 0 usually, because you would subtract 3. Okay? And so, this would be a multiplicity of 1. It's 2 different zeros with at least a multiplicity of 3. Or at least 2 zeros with a multiplicity of 3.
I'm getting like multiplicity like a line.
No.
Well, I mean the number.
The multiplicity is how many times that number is a 0.
I got you.
Okay, guys, if y'all did not remember that, or if that sounds, that's a big idea that you gotta know. A multiplicity is how many times that number is a 0. Amber, you write that down yet? Multiplicity is how many times that number is a 0. X would equal 5 3 times, because really that's x minus 5 times x minus 5 times x minus 5. How many times do we have a 0 of 5? 3 times. The multiplicity is how many times that number is a 0. So set it equal to 0. And solve. One of the zeros is power to the third. So, yes, because the power of 3 tells us that we have that factor 3 times. So that's 3 zeros. Okay? Now this also, just in case someone was asking this question, number 4, so what would be the degree for C? So you may have picked a different answer, but what would the degree be for C? What do y'all think third? Highest power? But hold on a second. This is that earlier problem that we worked, right? Yeah? What's the highest power here? 1, but when we multiplied it out, didn't we have negative 2x cubed? So it was actually what degree? Third degree. I need you to remember the difference between standard form and factored form. What can you easily see in factored form? What did we just find? The what? The zeros. And what do we know about the relationship between the number of zeros and the degree? They are the same. How many zeros do we got?
3.
We have 3. Now pause and remember. We have 3 different zeros, so that'd be 3x intercepts. But how many zeros do we have?
7.
0.
7.
We have 5 how many times? 3 times. We have 3 how many times? We have negative 3 how many times? So how many zeros is that total?
7.
7.
Okay.
Look, x equals 5 how many times?
3.
3 times. X equals 3 how many times?
3 times.
And x equals negative 3 how many times? Count them up. How many zeros do we have? 7. Okay? We got 7 zeros. So what degree is this polynomial? 7th degree. So when you multiply this out and get standard form, that's when you're going to see x to the 7th. But I need you to write down this big idea that the highest power is when we have which form? Standard form. When you have factored form, what do you need to look at? So, in factored form, what did we just look at? How many? How many zeros? And be careful about the language of how many x's, because it depends on the way the function's set up. But most clearly, it is how many zeros. Jamie, the reason why I say that is this. So, hey guys, y'all see this factored form right here? See that?
Yeah.
Yo.
Okay. So, how many zeros would this have?
5.
Why 5?
Because I'm thinking about the 3 and the 2 that have.
So this has 3 zeros, doesn't it?
Yes, 3 zeros and that's 2.
And this has
2.
2 zeros. So how many total zeros?
Wow.
5.
Also, the zeros like
So-
multiplicities, right?
Hey, hold on. Not quite. You gotta actually find the zeros. But Jamie, so the reason I'm bringing that up is because how many times do you actually see an x in this factored form? Well, 1 here and 1 here, so you only see it twice, right? But I have 3 zeros in this factor because it's cubic and 2 in that one because it's quadratic. So you have to think about how many zeros does each factor have. That is the best way to think about it. In factored form, how many zeros does each factor have? And find the total number of zeros.
So, Mr. Kenny, what Ms. Granberry teach?
Geometry and algebra 2.
Old lot of math.
Okay. What other question? So that knocks that out. We still need domain and range, don't we?
Yes.
Okay. Woo! Everybody needs a calculator in hand. Please go grab a calculator. Actually, for the sake of time, no, hold off on the calculator. Oh, so for the sake of time. Oh, that's really interesting, Tyler. Fix it. So right here, first things first, when we say domain, what's the big idea? What do we mean by domain?
The x value.
The x values. Guys, first off, if you were to just write x values above this, would that give me some evidence of understanding? So, it's all x values, yes. But guys, I need y'all to remember this because I saw a lot of answers written down with no justification. I need you to show me that you understand what a domain is. You can get it wrong, but if you say that, does that give me some evidence of understanding? Yes. When we say range, what do we mean?
All values.
All y values. Okay, so remember we use our interval notation. What number always goes first in that interval notation? No. Usually it is a minimum. So I need the minimum x. When I look at this graph, and it doesn't stop, it's going to keep going up, but it's also going to the... So what's my minimum x? It's what? Negative infinity. Minimum x. Notice how I've labeled this to identify what that negative infinity represents. That's strong evidence explaining why I put that number. What comes after the minimum? The maximum what? X. What's going to be the maximum x of that function? Why is it infinity?
Is that negative 9 right there? Is that 8?
Not just because it's on the right side. It's going. It's not because it's going up. Remember x. Remember x is which direction? Left and.
Right.
So it's not about going up. It's about going right.
Well, I said that.
Did you say right?
I said right, and you said no.
I did not hear you say right. That's my bad. Notice it's going to the right. So the maximum x is positive infinity. Range. Minimum y. And maximum y. What is the minimum y in this function?
The minimum.
Yeah. Now, I'm glad you said that, but I want you to look again. Does it continue going down forever?
No.
No.
Wait.
Can someone come circle the point that has the lowest y value?
I think that's.
Go on, Jamie.
Oh, okay. Alright, Jamie.
Alright,
Like this.
Circle the point that you think has the lowest y value. What do y'all think?
I
Y'all
believe
agree?
that's
Yo.
Yup.
Bad, Jamie, bad, Jamie.
Alright. So, thank you. So let's remember that this is on the calculator portion of your test for a reason. So I'm going to add a graph. So what was the function? 2
It's on
x
freeze
to the
though, G.
fourth? I know, but I got to type the equation in.
Oh, my
Plus
bad.
3x, but thank you, because I could have easily made that mistake. But minus 3x squared minus 11x plus, nope, minus 6. Okay? Okay, so I can't quite see it fully, but I do want to point out, you got a calculator. How could I find what that minimum is on the calculator?
Wait, no thing.
Analyze graph.
I'm going to analyze my graph to find out exactly what it is. And I'm going to go to minimum. Notice if you wanted the x-intercepts, what could you have done in here?
I might, man.
Zeros, right? So minimum. Lower bounds, poop. There's my minimum. So what is my minimum y for this function? Negative 16.
Oh.
What's my maximum y?
1.1.
So negative 16, tell me when it stops. So the maximum is infinity. I'll come back and answer the question on the TV over here. After that, we are continuing on with this unit. Good. Okay, one thing to be aware of. There's 3 terms. 1, 2, 3. So there is a maximum of negative 1, 0. But there's a minimum here, and there's a minimum here. Everywhere there's a term, that's an extreme. The game? Don't you have to have already bought a ticket?
NBA, Final Four.
Okay, we're good now. The red button.
Okay.
We're good.
And nobody in it. So nobody gonna leave the white book class with y'all. Keep checking out, keep checking out.
Alright, so we asked how to do a polynomial with a parabola present with multiple exclamation points and a question mark. So, right here, let's look at this. Okay. I want to remind you, actually, with a parabola, it's easier than if it's just lines. It's the same exact thing. What I would remind you also of is...
Wait, can I?
No.
The minimum maximum x. What was it?
Dog. Why did you already write that down?
Because who had lunch?
I put it up there before lunch. Good thing I recorded for you. Alright.
Oh, that's good.
Right here. Okay, g of x. Notice this parabola is x plus 2 times x minus 3. Like, that parabola is already the x plus 2 times x minus 3. That should make sense because, and don't write this out, but notice if I draw a line, that's the line y equals x minus 3. See how it has that same 0? If I draw the line y equals x plus 2, you see how it shares that 0? And when I look to the left here, what's a negative times a negative? Positive. You mean all of these positives? In between these zeros, what's a positive times a negative? Positive times a negative is negative. And then what's a positive times a positive? So that parabola right there is already the x plus 2 times the x minus 3. The only thing you have to do is we are dilating by negative 2x minus 4. So, if I want to dilate, no, we ain't sharing food, we learning. Or you can eat your own food. Alright, what food?
Eat your own food.
Negative 2x minus 4, I'm dilating by it, right? So what do I still need if that's what I'm dilating by? The line what?
The what?
What line do I need?
The linear.
Which line?
The G of it.
I already have g of x.
The negative 2x minus
Thank you. I'm dilating by negative 2x minus 4, so I need that line y equals negative 2x minus 4.
Just walking around crazy.
Red.
Did anybody ask me about food?
He said,
You don't want to be the first child to say it.
Okay. Y y equals negative 2x minus 4. Now what can I pull from that equation to help me graph it? My y-intercept is negative 4. How do you know it's negative 4? Right, b is negative 4, y's intercept is negative 4. 1, 2, 3, 4. That's 3, isn't it? 1, 2. I can count. Alright, what else can I use to graph this line? My slope is negative 2 divided by 1.
Did we keep the negative 3 right there?
So, down 2 to the right 1, or up 2 to the left 1. What else could I find from that equation really quickly to help me find the graph? What can I do to find the x-intercept?
You find a 0.
Can I set it equal to 0 and find my zeros? Right, so if I had taken that time, I could have also done it this way. You choose what you think is the best for you, but how many points do you need to graph a line? 2. So if I have my y-intercept and I have my x-intercept,
It's 2.
then I've got my line. Okay, there we go. So now I look at my zeros. Nothing has changed. To the left of that 0, what's my, by the way, what type of function are we going to have here?
Cubic.
Why do we know it's cubic?
Well, no, it's actually going to be a quadratic. There's only 2 roots on the x value.
Y'all agree? Just quadratic?
Yes, sir. To me.
I mean, that's you. I just
Yeah, that's what I'm
else agree.
saying.
Why do you think it's cubic? Okay. So one, we already did the standard form, didn't we?
Yeah.
Didn't we get an x cubed out of it? And now, Bakari, you're looking not at the zeros, you're looking at the x-intercepts. How many x-intercepts do we have?
2.
But how many zeros do we have?
3.
What the third one? Oh yeah, I see. From the x plus 2, x minus 3. And
Well, one, those 3 factors, but that's a double root. There's a 0 there from the parabola and a 0 there from the line. Double root. That's a single root.
wait,
Remember, we already had a parabola, so it's got to be a higher power.
I'll make it more different. Hold on. What was the first negative 2? From the x plus 2 to 0? From the x plus 2?
Right.
Okay.
Right? But also, you can just see it graphically. Doesn't the parabola have a 0
Makes
there?
sense. I know what you're talking
The
about.
line does? Okay, so we got lines, we got parabolas. Tyler, this parabola over here, positive or negative values? Okay, line is, so then what's my function going to have right there? Positive? Because what's a positive times a positive? So everything here is going to be positive. Now I look in between, right? Jaquel, is the parabola positive or negative values? In between those zeros. Huh? Negative? Why do you think it's negative?
Down.
Because it's what? It's going down? So like just because it's going down here? There's something else I need you to pay attention to and hold on to this. You're close to right, Tyler. Say that one more time. Okay, but why is the top up here positive and the bottom down here is negative?
It's below the x-axis.
Okay, we need to be careful about that, Tyler, because remember, if we're reading from left to right, it's actually decreasing. What you're really referring to is above the x-axis is positive, below the x-axis is negative. Remember, literally, you can see your y values right here. Okay, so negative times a negative is?
What's the what going on? Where you see the negative and negative from? The linear function in the U.
Tyler, or not Tyler, Bakari, what's the name of this shape of a graph that we've been studying?
Quadratic.
Okay, so the parabola, the quadratic,
Okay.
has what type of values?
Negative value.
Okay, and the line has negative values, and a negative times a negative is?
Okay.
Positive, okay, thank you. So how does that work? If I already had positive and it's going back to being positive, what's going to happen here? It bounces, right? Remember, do not go through. And I need you to check, because I saw a couple of people that when I just glanced at it, they had a 0 over here. Does one of those lines have a 0 all the way over here?
No.
No. Maddie, are you looking at your graph? Did you correct that? Okay. So then we have this 0 here. And then what's going to happen to the right over there? We're almost done. What's happening on the right side of that last 0? It's going down. Why is it going down? So notice with the line, those values are still going down. It's negative. The parabola has positive. And what's a positive times a negative?
Negative. So
Does anyone know a second reason why we should know it's going down?
well, because I mean, once we, since the line went up to down, we just have to go continue going down, right?
We didn't here.
It's not a double.
It's not a double root, it's a single root. So keep in mind double versus single roots. That single root, multiplicity of 1, means that we're going through it. It's only with double roots that we bounce. Okay? Questions, comments, concerns about this? Parabolas don't change anything. I'm not sure who asked that question on the board, but remember, parabolas don't actually change anything. Parabolas make it easier because instead of having 3 factors, how many factors do I actually have? Well, 2, right? Because I already had the parabola, and then I had added the line to it. Okay? Questions? Comments? Good, Chris? You tired? Me too. I'm ready.
Right, so we shall have to.
I still need to teach.
Wait, what about
You know, there's a weird thing where we finish the drill, we continue the learning. One thing I do want to point out really quickly, guys. Number 1, a lot of us missed number 1. Or we got number 1 right for the wrong reasons. The correct answer here is what? Anyone know? It is 2. Why is it 2 though? So notice there's a double root. How many zeros does this function actually have if we dilate by x plus 5? It has 3 zeros, right? But x equals negative 5 how many times?
2.
And x equals 3
1.
once. So there's 3 zeros. I can see that with the multiplicity, but how many different zeros are there?
1. I mean, yeah, 2 different.
2 different zeros. So how many x-intercepts are there? You got to remember the difference between a 0 and an x-intercept, right? You can have an x-intercept multiple times. You can only have, or you can have a 0 multiple times, but not an x-intercept. All right. Any final questions before we do finish up this mathematic activity that we started yesterday? Nope. Cool. Get that sheet out for me. I'm going to do one quick recap. Now I'll go ahead and tell you this. If we finish this early, then we can chill for the rest of the day, but we are finishing this lesson first. So half an hour.
If your whole class is off the basketball
They
game,
say
you
that
going to?
crazy.
No.
But
I got way too much to grade.
You ain't great, no collaboration.
Huh?
No, like the collaboration.
What are you saying, Ricardo?
Oh, have you been putting grades books?
No, I've been drowning in getting stuff off me. The mathematic one. It says mathematic in the bottom right.
Oh.
Yep. It says higher degree polynomial, says mathematic in the bottom right.
Mr. Kitty.
Miss Addison,
What is,
you stole something of mine?
yeah, that's, here it is.
Sit down, Mark.
My backpack.
How did I do that upside down? Hold up.
Are we keeping the DYUs?
Yes, I already made scans of them. I'll grade from the scans.
Mr. Kenny, it's so much behind.
I say you already graded.
Sit down, though.
I never said I graded them.
Okay.
There's a monster behind you.
What?
Go to the
What'd you say?
Okay. So, as a quick reminder, when we look at, which we ended up going over the vast majority of this. By the way, I do want to remind you, when we look at this demonstrate your understanding right here, how many extrema are there?
3, I guess.
Not just 3, I guess. How many are there?
3.
There's 3. Because what's another term we have started to use for extrema that can help us see it more clearly?
Fundamental thing.
No.
That's zeros in degree. Guys, yes, minimum, maximum, but there's a T word that I started using. Turns, right? If it turns, it's an extrema.
Okay.
So how many turns are there?
3.
3, right? So we should have 3 relative extrema, 2 minimum and 1 maximum. You can use your calculator to find those. But what I want us to look at is right here as a recap. So yesterday we answered this important question. How do you determine the maximum number of x-intercepts a polynomial has using the equation? Remember, I can always look at a graph and see it right away. Like over here, under the queens, how many x-intercepts does that function have?
1.
The queens?
Oh, one.
It has 1 x-intercept. Like I can look at a graph and know that. But what we want to be able to do is we want to be able to look at the equation and have a prediction about how many x-intercepts it's going to have. So what did we realize? What did we connect to figure out how many x-intercepts a polynomial could have? Well, I asked us to write this down before we left yesterday. The degree, the highest power, right? So notice when I look over here at the 9s, what degree is that? It's degree what?
4.
4. How many x-intercepts did it have?
4.
4, okay. When I look at the 8s, man, that's just, I'm going to turn this. When I look at the 8s, what degree is that?
4.
Say 3.
It's 4.
What, that 4 for real?
Yes.
Doesn't it say negative x to the 4th?
Hold on.
Did you just count how many x's there were and assume?
Oh, I didn't even see that last one.
So notice, we need to make sure we actually look at the highest power because yes, there are only 3 x's shown, but it is still 4th degree. And how many zeros did we have? Or how many x-intercepts? 4. Now, does anyone see an option where the number of x-intercepts was not the same as the degree? The kings, look at the kings. What degree is the kings? 6th degree. And how many x-intercepts are there? There's only 4. Now, there are still how many zeros there?
3.
There's still 6 zeros, so what are those other 2 zeros?
Imaginary.
Imaginary, right? Knowing that there's 4 real zeros, 4 x-intercepts, the other 2 zeros have to be imaginary. And so, this is why I say, is the number of x-intercepts and the degree always the same? No. Even if you look over here at the 2's, I want you to pay attention. I have labeled it still, and I can't remember if I pointed this out in this class or if it was just in my other class. But do you see how it doesn't just go through the x-axis right here? See how it curves through the x-axis? So it doesn't touch and bounce, but it curves through. So what type of root is that?
Double.
Remember, a double, it touches and bounces, right? To curve through like this,
Triple.
it's a triple root, 3 zeros. So 1, 2, 3, 4, 5 zeros. And what degree is it? 5th degree, right? So only 3 x-intercepts, but 5 zeros. So higher multiplicities and imaginary zeros can change the number of x-intercepts, okay? So please make a note of that. Big idea. Big idea. The degree is the what?
Is the highest, the maximum numbers of the x-intercepts?
Maximum number of x-intercepts.
Okay.
The degree is the what?
Maximum number.
Maximum number of
x-intercepts.
x-intercepts. You need to have that written down there under 2a. The degree is the maximum number of x-intercepts. Do you not have the sheet? Okay. Say again, Tyler? Dog, your face is nowhere even close to this because I've zoomed it in on the white book. Man. The degree is the maximum number of x-intercepts. So, if the degree is the maximum number of x-intercepts. So like if I have a 5th degree polynomial, how many x-intercepts could that 5th degree polynomial have? It could have 5, it could have 4, could have 3, could have 2, it could have 1. See, that's where we can't have 0. Let's look at this and let's think about why. Or let's look at this 3rd degree up here even. So look right here. I need y'all to remember and pay attention to this. In behavior-wise, we haven't quite talked about that yet. Hold on to that idea. I'll explain why we can't have 1 later. It's a later part of this. Okay. But I will point out, with an even degree, you can have 0. Yes, ma'am?
You just said we can't have 1, but I'm right there at 1.
No, we can't have 0.
You just said 1.
We can't have 1, we cannot have 0. For some polynomials. Some polynomials can have 0, some polynomials have to have at least 1, and so I'll explain why in a second, okay? Okay, but again, the maximum number of x-intercepts is the degree, but it can go down by 1, so 5, 4, 3, 2, or 1. Last thing that I wanted to, nope, that's it. What's the next question on 2A? What's the maximum number of turns? Okay, so here's what I want us to do. I want us to get up, I want you to start with the board that you're closest to, and I want you to see if you can find a pattern or relationship between something in the equation and the number of turns, okay? And so we're going to rotate every 60 seconds again, because I want you to go ahead and start trying to look for a pattern. What about the equation informs the number of turns? All right. Hey, by the way, Bakari, don't forget, D already tells you how many turns there are.
I see it, 3.
Yeah. All right, let's get up. Let's go to our white books.
Thank
We're going to find that pattern, that relationship. Look for the number of turns. Okay? Bakari, are you awake? Okay? So, jacks. Oh, there are no jacks, so 4 start there.
It's your turn.
Jaquel and Kennedy, keep your hands here.
You see him first, don't say that.
I said his name for a reason first, but he's still retaliating. We're supposed to go there. Alright, let's rotate. Let's see. So go to your next one. See if there's a relationship between the equation and the number of turns. And I will point out there are a couple of these that break the normal pattern. So look for a pattern that you think might hold true. Any ideas? What do you think? That's true, but how can I, what's the relationship? How can I look at an equation? Not the graph, look at the equation and know how many turns it has. Alright guys, I'm going to have y'all rotate again. Remember, what I want you to do is just focus on the equation. How can you figure out the maximum number of turns based on the equation? Maddie, any ideas? Say again. Something about the exponent? What do you think we're doing to the, which exponent? You think it's something with that one? Okay. Alright, keep thinking about that. See if that always holds true. Any ideas? Alright, let's rotate. Keep thinking. Relationship between the maximum number of turns and the equation. Hey, what do y'all think? Okay. And it's not quite. Okay. Now remember, one thing I will point out is I'm asking about the maximum number of turns. Not how many turns there are, but maybe the maximum number.
What?
What's up, Jamie?
I'm gonna wait. Are we not talking about it?
Yeah, we're gonna talk about it. What do you think? All right. So let's make one more rotation and then we're going to talk about those terms. Addison, what are y'all thinking?
Well, you gonna blank the building? No, it
Alright,
ain't.
so we're trying to focus on the equation.
What let me do with it?
None? There's something about the equation. Any guesses which numbers?
Numbers make the number of x's.
Oh, what?
Maddie, did your prediction hold?
Come on, do it. It's like
That seems to be related.
You can't be doing something.
Mel, have you been able to revise your idea? I mean, kind of. But let me ask you this, the second highest exponent, so like in this case, what's the second highest exponent? Yeah, so the second highest exponent, but the second highest exponent has typically been the degree, and then what is the
4 zeros.
So like if my degree is 4, typically what's my second highest exponent? 3, right? So it's 3 minus 1.
Miss Kenny.
Thank you. Thank you. Okay, so here's the thing. Alright, I am going to give y'all a chance to take a seat and write down the notes about this. Yeah, because I need us to see this. Okay, so let's come in here, not sit down yet, Jaquel. Okay?
Miss Kenny.
Excuse me. I thought I just said not to sit down. We're trying to have a conversation here. Okay? So listen. Alright, I've talked to a couple of groups. The groups I've talked to most heavily, don't say anything yet. I want to add some ideas in. What have we noticed about the equation and the number of terms? Corey, I talked to your group. Let's let a group that I haven't talked to yet.
I didn't get checked out. Oh,
Go. Can you please take that back? Because that's J Mike.
I ain't even.
I need it.
Get it. You didn't give it to him.
Thank you. Okay. Any patterns that we have noticed?
Please.
Chelsea, did y'all notice anything?
It's usually like the second highest exponent.
So it's usually the second highest exponent. I like that. I like the language of usually, right? So what breaks that rule?
It's like
I got wrong.
Bye, y'all. Bye.
Hey guys, what breaks the rule about it usually being?
Oh, slang nature.
Excuse me, hold on a second. I got a lot of giggling over here, which means we're not paying attention. I need us to learn this. What is breaking the rule about the second highest exponent?
So
when I look over there, the second highest exponent is 4, but there's only how many terms?
3.
3, okay, so that's not quite working. Anything else break that rule?
Can I explain?
Just say it. It's
Okay.
the number of.
So, no, I got it. No, we're talking about,
He asked a question if you got it. You don't got it.
Okay,
like right here,
I got it.
right here, see, 2 terms, right?
Right.
2 terms, 1, 2,
okay.
2 terms,
So you're thinking is how
3
many
terms,
times,
1, 2, 3.
how many terms have an x?
Yes, sir.
Okay, but let's look at the 3x cubed up at the front.
That was Master thought of, so give it a other.
My name's not Madison.
Addison.
Hey, how about we focus on learning? So, looking at the very front up there, okay? Looking at the very front, how many terms does the 3x cubed function have?
2. 2 terms.
There's 3 terms with an x. 3x cubed,
Oh,
6x
yeah,
squared,
so
negative 3x. No, there's a great thought. Okay. Anybody have any other final thoughts? I actually heard one other group come up with something else. Please don't. Kalia, Mel, what did y'all talk about in your groups?
We said subtracting we said taking the number that comes, I'm not clear.
Take-
Like you,
Okay.
minus the.
So usually, because notice a lot of y'all said, right, the second highest power, right? Okay, but really, that's 3 minus 1, isn't it? So it's third degree in how many terms? It's second degree in how many terms? It's what degree over here? Third, and has how many terms? Now, we're going to talk about that in a second, but usually it's the degree, and then what do we do to the degree? Minus 1, right? Notice that's not true over there with the eighths, because, let me reword that. In the eighths, if you were thinking it's just the second highest power, the second highest power in the eighths is what? 2. Second highest power is 2, but how many terms are there? 3. But does it still work if I do the degree minus 1? So the maximum number of turns,
Need to write this right.
in a second is n minus 1. That is my degree. The maximum number of turns is n minus 1, where n is the degree. However, could it be less? Yes, but I need y'all to pay attention to something with that. Okay? Over here, with the 6th degree, Kalia, can you turn on the camera over here? So, what is the maximum number of turns this could have?
6.
It could have,
Wait, no.
so the max would be 5.
5.
The max would be 5, but how many are there actually? How many turns?
Oh, 3, I'm tripping.
So there's actually 3 here, right? Over here, this was a 5th degree. Over here, this is 5th degree, but how many actual turns are there?
5.
Sorry, 5th degree could have how many turns?
Turns, 2.
Guys.
2 turns.
It could have 4.
It could have 4. How do we know it could be 4?
2 to the
Degree.
The degree minus 1. Remember, the maximum is the degree minus 1.
Okay.
And so what's 5 minus 1?
4.
4. So it could have 4, but how many does it actually have? It actually has 2. Notice how that number of turns is 2 less than the maximum. This number of turns is how much less than the maximum? 2 less. Remember, the degree minus 1 is 4, and how many turns does it have? 2. So, here's what I need us to recognize is the maximum number of turns is the degree minus 1, but turns, or extrema, come in pairs. So if it is 6th degree, so for example, 6th degree, what's the maximum number of extrema? 5, right? N minus 1 is 5. But they come in pairs. So what's another option? It could be 5, or it could be 3. Or, what else could it be if they come in pairs? Or how many? Say it louder. Or 1. Guys, they come in pairs. The idea is that it needs a max and a min each time to balance out. And so, if it's 6th degree, it could have 5, 3, or 1 turns. Man, y'all look real comfy back there. Let's say it's 9th degree. How many turns or how many extrema could it have? Its maximum is 8, but it could also have 6, 4, 2, or how many? Not 1, or 0. They have to come in what?
Pairs.
Remember, those are x-intercepts. And only sometimes Addison. I'm going to explain why I say sometimes in a second. But notice, the maximum is the what? Degree minus 1, but they come in pairs. I need you to write that down. Big idea, super important on 2A. That's still 2A. Hey, bro, get over. All the stuff in purple, the maximum number of turns is degree minus 1, but extrema come in pairs. That's something we should already know because we're engaging in the conversation. Yo, guys.
Are you just seeing her grab?
We shouldn't even been back there in the first place.
I'm cleaning my seat, just seeing her grab.
Tyler, there's no reason for you to have been behind the desk. Macari, the same deal though. No, bro. No, bro.
At a 5,
Shouldn't have been
right?
there. Say again?
5, right?
Yes, that's a 5.
Sorry.
Because if it's 6 degrees, the maximum is n minus 1. 6 minus 1 is 5.
Why would one be 3?
We'll write it as, because 6 minus 1 is
Still
5.
2a.
Last 5 minutes.
Talking about the 3.
We ain't done. We still got 2b and 2c to go.
I know you're talking slow on purpose.
Try to finish. Say again. Mathematic 2a.
I bet you learned touch same. Yes. Wait, Miss K, I'm gonna say
Hey, I got 5 minutes. Hold it. Sorry, we got to finish this.
Okay.
2b. I want us to look just quickly around the room. What determines if the end behavior is the same or different? So just looking at the stuff around the room, can anyone tell a pattern when the end behavior is the same versus when it's different?
Right there, both the lines in under the X.
Well, both of the ends are the same, right? So what's going on over with those two where those ends are the same? What do we see over there?
They're both negative.
I'll give you a hint. Look at the degree. What's happening with those degrees? They're what? Look at the degrees. What's the degree for both of those graphs? 4, okay? Does anyone see any other polynomials that have the same end behavior? This one, which is degree 2. Does anyone see it?
1.
So does anyone see another one that has an even degree?
0.
Oh, listen to the question. Does anyone see another even degree around this room?
Yes, right here.
About the kings?
6.
The 6th degree over there, is the end behavior the same?
Yes, so the numbers.
So end behavior is the same. When n, by the way, when we say n in math, what am I referring to? The degree. N is the degree when n is even. So if the degree is even, the end behavior is the same. So when is the end behavior different?
When they're odd.
So let's look at all the odds. Is the end behavior different?
Yeah.
Yes? Is the end behavior different?
Yeah.
Okay? So when the degree is odd, the end behavior is what? Different. Now, you packed up? Put it on? Just not caring anymore? So, what I would point out about this is, remember how I said sometimes it has to have one x-intercept and sometimes it doesn't? If the end behavior is different, that means we're going from negative infinity all the way up to positive infinity. If you go from negatives to positives, what number do you have to cross?
0.
A 0. So an odd degree has to have at least one what?
0.
0, well, however, whatever the degree is, that's how many zeros it has, but it has to have at least one what? X-intercept. To go from the negatives to the positives, an odd degree has to have one x-intercept. What I will point out here though is this. So I want you to think about this graph really quickly. What type of function do you think this would be? What degree would this probably be?
2. Wait, no, hold
Come
on.
on, function, I think
0.
What degree?
Q.
What is degree? The end is probably what?
3rd degree.
Nope, not 30.
Gang, they going both ways, bro.
You see how it's going both up? So it has to be an even. There's some, we can get more specific with it though. I heard someone say 4. Why are you thinking 4? Well, let me ask you this. What is 4 minus 1? 3. And how many turns do I have?
2.
I have 3 turns. So it is probably what? 4th degree. But I want you to notice, does that 4th degree have any x-intercepts? No, it still has how many zeros?
Only 4 of them.
It's still 4th degree. They're all what? Imaginary, right. So that's what I need us to recognize out of this. We'll have one more thing we cover after Thanksgiving break. It's just how to know exactly what the end behavior is. But fourth degree, three extrema, so probably fourth degree. Notice the number of extrema can tell me what the degree is. So you need to remember how to relate the extrema to the degree. I hope y'all have a fantastic Thanksgiving break. Lots of turkey, pecan pie, all the good stuff. Rest, recover, come back ready to learn for 2.5 weeks before those finals. Yeah, finals.
That was a semester exam.
Say again?